Hello everyone, I am Professor Nayana Snai, Department of Information Technology, Parvatibai Genba Mose College of Engineering, Wagodi, Pune. So in this session, we'll see the Agile practices. So Agile development is supported by the numbers of practices. It includes the different areas like the requirement analysis, like the designing, coding, testing, project management, process, quality. Some of the important Agile practice has been listed here. The first one is the pair programming, second is the refactoring, third is the test-driven development, and fourth is the continuous integration. So the agile development suppose this type of different practices. Now these practices also we can call as the methods or we can say the provisions in which the agile development has been built. So we will see one by one. First, let us see the pair programming. So it is one of the agile practice or the pair programming. In this method, two programmers are working together on the same machine. As we can say, they share the screens, they share the keyboard, mouse, and continuously collaborate the same design with algorithm, code, and test. One programmer is called as a driver that has the control of your keyboard, mouse, and the activities, which is implemented in a code and writing the code, you can say the writing the test cases. And the other one is called as a navigator, which will continuously be will able to observe the work which is written by the other one. So in pair programming, pair means two. So you should always understand pair means two. So two people's work on the same code, on the same machine, which will share the same screen, same keyboard, same mouse. So together they will develop the application. Together they will develop the program. So one is called as a driver, which has the control of your keyboard, mouse, and the activities which are done on your screen. So he is able to write the code. He is able to test the code. And the other is the observer. That is, he is continuously viewing or identifying the defect who the other one is writing. Okay, one will write the code, one is having all the authorities, and the second one who will continuously observe the work. He will suggest any suggestions, he will identify the defects if there are any. So because of these two things, it is called as a pair programming. So the observer can also suggest the improvements in the code. With this method, the programmer who writes the code can concentrate on efficient coding, and the observer who is seeing the code or who is able to observe the code will suggest the improvement. So by this you can get the full concentrate and minimum error and a good software application. Many agile development process uses the pair programming. So what is the benefits of the pair programming? The first one is we can say many mistakes are detected as there is at the time of your typing rather than a quality testing. So numbers of errors while we are typing the code is eliminated. That is, your syntactical error can be eliminated. Why? Because one is continuously sitting and observing your code. The second is design becomes better and the code becomes shorter. Why? Because there are two people who are thinking about the code. One is writing and second is suggesting the code or suggesting any improvement. So definitely the designs are improving. The team solves the problems faster. Why? Because two people work on the same thing. The project end up with the multiple people understanding each piece of the system. So if two people are working on the same thing, so they are easily understandable. The code is easily understandable to other also. So the people learns to work together and talk more often. So giving a better information flow and team dynamics. So if the people are working, so they are building their skills, they are building the team. So working together and talking to each other is giving the better information flow, better understanding, and the team dynamics. People in this pair programming, people enjoy their work. Why? Because there are two people who are working on the PC. So if you have any partner to work on, definitely they will love their work. So there are different tools for the pair programming. We can say the VNC is one of the tools, Screen Hero is another tool, then Visual Studio Anywhere is one of the tool, and then Microsoft Lens. So these tools are used for the pair programming. Suppose now if you are considering the physical, if you are thinking physically how the pair programming will work, so two people can be sit on the same PC, but if there is a remote location, So you have a different tools to access the same PC from the remote location. So two people can share their screen if they are remotely placed. Suppose one in an office and one at home. So two people are sitting at two different locations, but they are accessing the same screen. They are sharing the same screen. So that is one of the example of the remote pair programming. Then we'll move to the refactoring. So refactoring is a disciplined technique for reconstruction of an existing body of the code. So the internal structure is affected by the refactoring, but you cannot change the external behavior. That means you cannot change the functionality. Whatever the functional requirements are there, that are not modified in refactoring, but the non-functional requirements are modified. So then what are the non-functional requirements? Like your performance, like your complexity, like your throughput. So that requirement can be modified, but the primary requirement cannot be modified by refactoring. Okay. It is the process of reconstruction the existing code. The changes are made without affecting the external behavior. So it does not change the functional requirement of the code. It will just change the non-functional requirement: efficiency, performance, throughput. So numbers of advantage like improving the readability, reducing the complexity, reusability. So this refactoring is done in a small unit. So it is also called as a SMELL, SMELL. It is also pronounced as a SMELL. So it is a short code which is modified and transferred. So you cannot have a lot of errors afterwards because you are modifying very small code. That is called as a SMELL. So it does not change the functional requirement. It will always change the non-functional requirement. Refactoring is done for improving things. Okay. For if the existing code is there, it is too lengthy. So refactoring is done for minimizing the code. So shorter code with the bigger functionality. So refactoring is done for that purpose, which will not modify the external behavior, that is a primary behavior of that application, but which can modify the non-functional requirement, which comes your performance, your efficiency, your complexity, your throughput. Okay. So there are two different categories of the refactoring. That is, first is the maintainability and second is the extensibility. So these two factors are affected by the refactoring. Your next is your test driven development. That is TDD is also called. It is also called as a TDD. It is a software development approach in which the test cases are developed to specify and validate what the code will be do. So in this, what happen if you are going to add a new test cases or if you are going to add a new improvement. So firstly, it is done on the prototype. It is tested. If the test fails, it is refactored. If test gets success, then it is added to the application. Okay. So this software development process relies on a repetition of the short development cycles. Changes in the software are quickly and easily modifiable. So if you see the TDD, the first approach in the TDD is to run the automated test before the actual development application. So here I have also written the TDD, that is a test driven development, is a process of developing and running the automated test before the actual development of the application. So firstly the test has been happened for that particular code and then that code is added to your application. It is sometimes also called as a test first development. That means test first and then add to the application. So it has the shorter development cycles. The simple concept of the TDD is to write and correct the failed test before writing the new code. So whatever first fails, you have to correct it, add to the application, and then you have to create a new feature, or if you want to add the new feature. So this helps to avoid the duplicate of the code as well as write a small amount of code at the time of order to pass the test. So if you are passing that test, then only you can add the test. If you are not passed, you have to refactor. Again, I am telling the TDD uses the refactor. If you are failing the test, you have to refactor it, you have to change the code, and then you have to test it, and then if the test gets succeed, if the test get pass, then you are adding to the application. So the test driven development is nothing but testing the application, testing the code, or testing the existing code, then creating a new feature, testing it, and then adding to the, if the test gets fail, then you have to refactor, change the code. If the test get succeed or test get pass, then you have to add to the application. So that is your TDD. You can see here there is a TDD cycle defined here. Number of stages are there. First is to write the test for a particular code, make it run. So if the test fails, you have to refactor it. Okay. Again you have to write a test for that, make it run, again change the code to make it right. Okay. If test gets passed, then you have to go for adding to the development. So here you can add a test, execute the test. If test fails, you have to make the changes. That means you have to refactor. If the test gets executed, then you are ending the process. If again test get fail, then you have to again make the changes. Okay. And if while adding the test, if the test is added successfully, if it is executed successfully, then it is directly added to your application. Else you have to refactor each and everything. So that is stage driven development. Next point is your continuous integration. So continuous integration involves processing a clean build of the system several times per day. That means number of people built is added or committed is added to the particular PC, or we can say the particular server. So what happens, every day the update is available. Okay. So continuous integration involves processing the clean build of the system several times per day. Usually the different tools are using for the continuous integration. One of the tool is the cruise control, which uses the and various source control systems. So it merge all the development copies of the work together frequently. This tool is used for what? To merge all the development copies. Suppose there are 10 development people or 10 developers sitting on the 10 PCs. So what this tool will do, everyone is using this tool. So what this tool will do, they will merge all the copies of that development teams, or we can say the developers which are sitting at the 10 PCs frequently. Whenever they are committing the code, they are adding to the main code. Okay. Suppose that there are 10 applications which are running on 10 different PCs, or 10 different feature or 10 different functions developed by 10 different developers. So that after they are committing the code, that code gets added to the main functionality. So what happens, it eliminates the multiple error which comes in an integration phase. Okay, it prevents the numbers of error which comes in an integration testing, or we can say the integration phase. So the principle of the continuous integration is to maintain a repository. That means the main repository you have to maintain, where each and every code get pasted, or we can say that get committed frequently, get added frequently. So in the main repository, every code, every piece of code by every developer get added frequently. Whenever they are committing the code, it is get added to the repository. Then automated build is there. As they are adding the code, that means you are integrating the code, and integration testing happen itself. So it is self-tested. That makes a build self-tested. So everyone commit to the baseline every day. So every person who is developing the code commit the code, and it is added to the repository. So everyone is committed to the repository, and it keeps the build fast. So building the application speed is fast. Why? Because different people's working on different PCs or the different piece of code, that code gets added to the repository. When they are adding to the repository, simultaneously it gets tested. That's why we are eliminating the numbers of errors at the integration phase. Okay. So there are also tools available for the integration testing. The first tool available for the integration testing is the Apache Quantum, then Atlassian Software Systems Bamboo, then we have Automated QA, Automated Build Studio, Automated QA, Automated Build Studio, and Cabal. These are the tools which is used for the integration testing. And last is the exploratory testing and scripted testing. So this will cover in the next session. Okay, thank you.